In the previous units, we have explored how, using, in a way, mathematical rules and patterns, we can construct compositions that have an aesthetic unity and like kind of a musical sense. Right now, we need to move on refining some of these concepts and introducing more the idea of simultaneity of sounds that in the musical language corresponds to harmony. Harmony will be one of the, if not actually the most important aspect of music that we will be looking at from the point of view of complexity and complexity theory. The basic concept in harmony is the idea of chord. A chord is a combination of notes that are assembled vertically. That means they sound together. And we can hear here a chord played on a keyboard. This is a C major triad. It's a combination of 3 notes played one on top of the other. This is an example of a 3-note chord. It's called a triad, but of course you can combine as many notes as you want in the in a chord. But in the classical music tradition of Western music tradition, the triad itself is a foundational concept in the idea and the theory of harmony. So triads can be constructed using all the notes of a scale. So we introduced the idea of scale before. We looked at how we can build scales also through the notebooks. Each scale, each note of a scale can be the foundation for a chord on that particular note. And so you see in this image, for instance, you have all the triads that can be constructed over a C major scale. Now, of course, you can have more than 3 notes. You can have 4 notes, 5 notes, or more complex situations and more modern music. You can have a stack of different notes with higher dimensions. We want to explore this harmony space. Given at our disposal our notes, our pitches of the equal temperament, the 12 pitches of the equal temperament scale, we want to understand or measure how many of these chords we can construct. For instance, using permutation and combination of different dimensions. So we can construct a dictionary of all the possible combination of notes, vertical combination of notes between a dimension of, say, 2, that is the minimal superposition of 2 notes that are playing simultaneously, or even 1, like the unison, and 12, that would be, we use all the pitches that we have at our disposal in the scale. So if we try to build a dictionary or kind of measure how many of this combination we can construct, then we have a measure of how many chords they can exist given the raw material, our notes, our pitches in the scale. So if we consider a 12-note space, we have a number of chords that we can construct that is of the order of 4,000. And these numbers, I will explain a little bit in a second, how we can actually reduce these numbers to like the minimal units or the minimal combinations of pitches. But if we expand this to a temperament where instead of having 12 pitches, we have 24 pitches, so we introduce the idea, for instance, of quarter sharps and quarter flats, then we get to 16 million different combination of chords. And if we look at the keyboard here, a keyboard with 88 keys, and we try to evaluate how many combination of keys we can construct, then we have a number that is larger than the number of atoms that you have in a centimeter cube of a material. I mean, 10 to the 26 different chords. Now, this very large combinatorial space can be reduced by operations that take into account the equivalence of pitches, so that every C in the keyboard is actually one single entry in this large combinatorial space. We can reduce chords by transposition and inversions, and we can introduce all these mathematical operations, if we want, on chords that we discussed in previous units. This enormous space that we have constructed with all these combinatorial possibilities can be reduced by using operations on the pitches of our chords that we have introduced in the past units. And so here, for instance, I'm reintroducing or showing again all the possible operations that you can do on a pitch, but also on a chord, so a collection of pitches, or a pitch set, as is called in modern music theory. And all these operations reduce this large combinatorial space to minimal units. But still, this is an enormously large combinatorial space anyways. So the four operations that are foundational to contemporary music theory are, or at least pitch set theory, are the octave equivalence, so the fact that all the octaves are equivalent. They doesn't matter if we are on a higher octave or a lower octave, a C is always a C. There is permutation, so I can do a permutation of chords, of pitches within a chord, and that correspond to the same set of our space. Although in terms of music theory, this might be also kind of questionable, but we are not going to get into these details at this stage. Another very important one is transposition. I can transpose my pitches by a constant shift, constant unit, and so I can shift from one chord to another chord just by translating all the pitches by a given unit. And then there is inversion. There is very particular operations in a pitch class set, where in terms of our perception of the musical element, an inversion is the operation that transforms a major triad in a minor triad. And this is an example, for instance, between a C major and a C minor chord. Going from one to the other, this is an operation of inversion. In this slide, we are starting from a collection of pitches here. This is just a collection of 7 pitches. And using only the pitches of this scale, we can construct all these sequences of chords. And you see here different triads where the pitches are combined to form the harmony of that scale. Now, this is an important concept in what we call the traditional harmony or tonal music, where the scale gives us this kind of framework that is used to define also the harmonic progressions within that collection of pitches. Now, the library that we have been working with, and in particular the class note that we have introduced in the previous notebooks, has a method that is harmonize. Harmonize is a method that, given a scale and given a particular interval and the number of pitches that we want to have, produces a collection of triads. And you can try this in your notebook associated with this module. So in this particular class and method of the class note, The scale is a scale of notes, so we can decide any kind of number of notes we want to have in that particular scale. The interval defines the quantity between notes in the chord, so if we want to have a regular triads, then we would have 2/3, but we can construct any combination that we want. And then the size is the number of pitches in that chord. And you can explore all these functions with the notebook that is associated with this module. There are concepts here that are kind of foundational for modern music theory. And one of this is the concept of transposition when applied to this harmonization of a scale. So we can transpose our chords, as I showed you before, the operation of transposition as moving the whole chord, all the pitches of the chord by a constant quantity, in absolute terms. So I can define transposition on all the chromatic pitches and say I want to shift this chord, each note of this chord by, say, 1 semitone. But I can also do a transposition where instead my reference system is not the chromatic scale, but is actually the scale itself. So if I do that, then I transpose or I move all the pitches by a particular amount relative to the scale and not to the chromatic aggregate. So these are the two modes of transposition that are actually coded into the class note. One is the so-called regular transposition, or I could call it regular transposition, where I add a constant number of semitones to all the pitches in the set. So if we start from a C major chord 0, 4, 7, C, E, G, I can add 1 semitone and make it C sharp, F, and A flat. So we call this the transposition along the aggregate. The tonal transposition is instead the transposition along the scale. That means if I'm on C major, the only pitches that I can go to in transposing are pitches that belong to that scale. So in this case, instead of transposing, say, by 1 semitone, here I transpose by 1 step on the scale, and so I go from C, E, G to D, F, A. And this is a transposition along the scale. There is a third mode of transposition that is associated with the chord itself, that can be framed within this idea of transposition along the collection. So you can transpose along different combination of pitches, you can transpose along the chromatic scale or the regular diatonic scale or the scale internal to the chord. All these concepts are central to what my friend and colleague Dmitry Timochko at Princeton University will talk about in his contribution to this course in the next couple of modules.